Hello and welcome to the Intel Network and Edge panel on private networks, deployments, learnings and the road ahead. I'm Guy Daniels, Director of Content at TelecomTV. With ubiquitous 5G, multi-access and edge computing connectivity, organisations can benefit from custom private network solutions that will not only help solve their needs in terms of connectivity, security and performance, but will also make a significant social impact in areas such as education. Well, joining me now to discuss how the rapid growth of 5G and private networks is enabling new options for businesses and institutions are Caroline Chan, VP and GM, 5G Infrastructure Division, Network Platform Group at Intel, Jeff Bankston, Principal Private Network Segment Leader with AWS, and Prasad Ramapalli, Expert Advisor to the California Emerging Technology Fund and CBO at Meg Computing. Hello everyone, very good to see you and thank you all for taking part in our roundtable discussion. Well, let me ask you all this first. Why do we even need private networks? What would you say are the top challenges that you are solving with private 5G networks, and why can't public networks address these? Jeff, perhaps I could start by asking you first.
Absolutely, thank you. I think for us here at AWS, it's all about pushing compute and cloud as close to the edge as we can get. This is to enable, advanced capabilities such as artificial intelligence and machine learning, which is going to enable things like cloud robotics and augmented reality, virtual reality, a lot of process improvement type of technologies that's really going to require that presence of more intelligence at the edge. And really, so that's how we're focusing our attention, is to help enterprises in that area to address that challenge of getting that intelligence closer to the edge and really extending that ubiquitous cloud programming layer out as far to the edge as we can get to lower latency for all of those applications I just said. So to me, that's the biggest challenge that we're working on addressing at AWS. I think the next is really enabling the developer community to develop value-added applications for enterprises using the power of the cloud to do that. I think previous to a few years ago, you might have had issues being able to extend that development out to the edge. I think that's something that we're really helping enable at AWS for private wireless networks.
Thanks, Jeff. Prasad, what's your views? Why do we need private networks?
Yeah, thanks, Guy. I'm going to start with just laying out the macro view of the pain points that we see bearing the lens of the California Emerging Technology Fund, which is trying to solve this digital inequity and inclusion problem for a large part of the underserved masses in California and North America. Roughly about 25 to 30% of African Americans, Latinos, and the rural areas really have marginal internet to none. And this problem has been there for multiple decades. And there's really a need for a breakthrough, disruptive connectivity wireless network capability that is going to address this need at the right predictability, at the right cost point. And that's what private LTE networks promise to do. Wearing my project lead hat, where we are looking to deploy private LTE networks in the school to home space, there's roughly about 13 to 15 underserved parts of California that have been earmarked for these communities that really have very little bandwidth and access in the school and the adjoining community areas. We see that the use of Wi-Fi just doesn't cut it. And there are three specific challenges that I want to talk about. One is the coverage rate and the range that is needed for the adjoining community and the school, roughly about 1 square mile, with about perhaps 1,000 to 1,200 community dwellers and students. And the coverage rate and the range of private LTE is at least 4x in the indoor networks, at least 10x in the outdoor space. And so it provides the right horsepower, both in terms of bandwidth, quality of service, and most importantly, the cost point. This community really taps out at $10 to $15 per user per month. And we have to deploy a technology that addresses this cost point. And I strongly believe that private LTE does do all of this, as we are finding out from our early pilots.
Thank you, Prasad. And Caroline, what are the challenges we're trying to solve with private networks, and especially with new private 5G networks?
Yeah, in fact, I will echo what Jeff and Prasad said. Really about private connectivity, private LTE, private 5G is about deploying the right connectivity solution at the right location for the right use cases. There's a role the public network already playing, and Intel has been driving that a lot with the virtualization, the cloud, native LTE, and 5G. But if you look at the private network, in a way that, like Jeff really alluded to, that you start driving cloud to the edge with the connectivity. And more importantly, one of the aspects around security, control point of the data sovereignty, it gives the enterprise a lot more say in how the connectivity is rolled out, for whom and under what condition. And we do see that as a very new market segment that's being rapidly developing, and much more powered by the cloud and by all the work that we've been led at the last 10 years in my career here in Intel, driving a cloud native network, driving virtualization and software defined network. It started culminating in the point today that we're able to roll out a private network solution for the enterprises, empowering with a whole new group of ecosystems like here.
Well, we've discussed why we need private networks, so let's move on to who is using them. Caroline, which verticals do you expect to show maximum penetration of private networks?
What we're seeing today so far is definitely led by industrial, a lot of the manufacturing plant. I think Jeff alluded to the robotics side. We're seeing that first out the gate. We have a multiple engagement now directly with the industrial vertical and element. But what we're talking about here today about the schools, and Prasad alluding to, there's so much digital divide, even in the countries like United States, let alone the rest of the world. We do see the digital equality, the access to digital services be equalized among different incomes and different places and different spectrum of our society is becoming a rapid adoption of private networks.
Yeah, thank you, Caroline. Well, let's stick with this theme. Prasad, the FCC has recently approved, $7.2 billion of emergency connectivity funds for schools and libraries. How do you see this accelerating the deployment of private networks in the education sector?
Yeah, great question, Guy. Just as background, this particular connectivity fund is the Emergency Connectivity Fund, was incorporated into law. I think it was in March of this year for roughly $7.2 billion, as you mentioned. And it's a great catalyst to accelerate broadband, especially targeted at underserved schools that have low access to the internet, as well as the adjoining communities where the students live, and they are trying to adopt remote learning at the right level of efficacy and adequacy for education and their homework, and the community that is going to be leveraging these services. So while I'm excited about it, when it comes to private LTE, the particular ECF funding that has been enabled has restrictions to really adopt that. It allows for deployment of private LTE or self-provision networks only on an exception basis, where the onus is on you, the person who is looking to deploy these private networks in these communities, to exclusively prove that traditional service providers either have no access in the space or do not have sufficient access, and therefore there's a case for deploying private LTE networks. I strongly feel that this is putting this emerging white-hot technology on the wrong footing with other existing capabilities that are there today. And there should be a democratization of all aspects of network access and technologies with the legislators. And my hope is that that's going to happen soon. The other point to make is the ECF is a one-time fund that starts in July of this year and ends by June of next year. So one hopes that with the emerging infrastructure bill that's being passed through the Biden administration, this will become an ongoing fund to enable universal access of broadband. And the legislation will also allow for private LTE networks as an equal citizen versus other service provider technologies, so that there's rapid innovation and competition to drive the right price points of affordability at the right quality of service and predictability.
Yes, thanks, Prasad. Jeff, there must be challenges here. What would you say are the actual challenges of deploying private networks in school districts? And how can market leaders such as yourself, AWS and Intel, how can they help remove some of these barriers?
Yeah, so I think a couple things I'll touch on. One is just the deployment of these networks and the implementation of these networks really is a challenge for anybody who hasn't deployed these kinds of networks before. And Prasad and I and the folks from Intel, we're working on a project now where we're living through that. You know, it's difficult to acquire sites if you have to change sites because of RF requirements. Sometimes that can be difficult due to permitting processes. That can add weeks and weeks, maybe months to deployment schedules. And so that's one of the biggest challenges. It's a challenge the service providers have been dealing with for years. And now we see it in school districts and other industries as well. One of the things we're helping to solve that is by pulling together an ecosystem of deployment firms and system integrators to help take the burden off of school districts to accomplish that. I think that's something that school districts, until they get into dealing with a wireless deployment, they don't realize how difficult some of those things can be. And so by bringing in an experienced player can help alleviate some of those issues. I think the second thing I would touch on is the orchestration of these networks. Once again, IT departments at not just school districts, but in enterprises as well. These IT organizations don't always have the expertise to put together a full 3GPP network of LTE or 5G. It takes, traditionally has taken a lot of specialized kind of experience. And so what we're working on at AWS is to help orchestrate a lot of that, to help move to more of a zero-touch framework on deploying these networks. And we believe that will help a lot of enterprises and school districts deal with deploying of these networks. So I think those are the two biggest challenges that I personally see.
And Prasad, what are the challenges you see in deploying private networks in school districts, and how can market leaders such as Intel and AWS help to remove some of these barriers?
Yeah, thanks, Guy. Private networks are hugely disruptive in addressing, in my mind, three key pain points that these school districts and the adjoining communities see today. Number one is when compared to Wi-Fi, which is kind of the foundational service that most of these communities and schools are using, the coverage rate and the range of deployment needed for a 1 square mile area, which is typically a school in the adjoining community, are just not afforded through a number of Wi-Fi hotspots that can be spread across this area. And this is where private LTE with its capabilities in coverage rate and range just shines, because it's 3x or 4x more powerful in terms of coverage indoor, as well as 10x more powerful in terms of coverage outdoors with the radios that are available. Number two, the quality of service and predictability, especially in dense networks, where in the community you have 3 or 4 students along with their parents trying to access the network. A Wi-Fi hotspot simply chokes at that point. And this is where a private LTE network can be excellent in actually meeting and smoothing out these peak loads and making sure that the performance and the quality of service is met. And lastly, perhaps the most important is the cost. The cost affordability for a community or a user per month is roughly about $10 to $12 a month. And there is a need for this kind of a disruptive technology to meet that cost point. And through our early trials, we are already seeing that this kind of cost point is being met.
Caroline, please.
Yeah, I just wanted to chime in on what the two gentlemen have said. When we started doing private networks, so first of all, Jeff and I both came from the telco side, right? Where a network, especially a public network, someone the carrier is really deployed, it should be viewed as a specialty. You need to have RF engineering degree to do that. But in reality, when you go into the private network, like Prasad just described really, really well, like in a school, an IT department, we got to make it so automated, this network in a box concept, ready to deploy software, fully automated, zero touch, as easy as a Wi-Fi AP. That is really what's needed to take this into proliferation. Stop treating it like you need a PhD. Treat it like a IT box, IT software. And here at Intel, we've been driving towards that, thankfully with a large group of co-travelers, people who see eye to eye. What AWS is doing in the cloud, there's no reason that we could not do this in a connectivity world. And we have to, in order to push this to the far-fetched areas, not just in Sacramento School District, but all around the world, in Nepal, in Africa. There's no reason why we can do that, to push through the bridge, the digital divide. I've been using this term 5G for good, but now I think we should take it as a network for good. That's what it takes for digital transformation. So very thankful for the ecosystem together. And thank you, Prasad. Thank you, Jeff, for coming on this journey with us.
Yeah, thanks, Caroline. And as you said at the beginning of your answer there, you come from a telecoms background, as does Jeff. What is the role of service providers in private networks, Jeff?
Well, I think they provide a key link in the value chain really for private wireless. And we're doing a lot of work with service providers around the world. In countries like the US, where you have widely available CBRS spectrum, it's relatively easy for enterprises to build their own private wireless networks. Although we do see in the US that service providers are very active in this space. And I'll reference the work we're doing with Verizon on private MEC with Corning that we had a press release on a few weeks ago as an example of that happening in the US. And there are other examples of that as well. In countries like Germany, they also have made spectrum available for enterprises. Although there, once again, we do see the service providers heavily active in building private wireless networks for enterprises. I think the thing to keep in mind is that at the end of the day, enterprises aren't necessarily enamored with the technology of private wireless and private 5G. They're looking for positive business outcomes. And so some of the work we're doing on automating and zero touch frameworks around private wireless are very helpful. But the service providers do bring a ton of expertise on how you actually build, deploy, and maintain a network. They run five nines networks all the time. And so I do believe they provide a critical link in the value chain. And remember, there are a ton of countries around the world that do not have spectrum available directly to enterprises. And there, obviously, the service providers are going to provide a really critical link in developing private wireless networks. I think the thing that we can help from an AWS perspective, and Intel could help as well, and others, is that bringing that capability to develop value-added features and functionalities, and bringing together a full ecosystem of all the thousands of applications that are built to run on AWS that service providers can bundle. They can curate and bundle a list of value-added applications that they can bring to their enterprise customers, which is a capability that really is only developed in the last several years with the advent of AWS Cloud. And so really, service providers plus and AWS really provides a really great value statement for enterprises.
No, I have to agree with Jeff. I think the private space, interestingly, really sits in the middle, right? We started with the carrier network, and then you have the enterprise side, and then obviously the cloud sits in the top. But the private network is the intersection of all three domains. We do see them coming together. So the expertise of operators that knows how to operate a telco network, the IT department of the enterprise have certain demands of usability, and AWS will bring a lot of the automation, the cloud economics. I think this is a perfect intersection of all three Venn diagrams together. Ideally, in the middle, you have something easy to deploy that meets the IT enterprise easy button requirements, and then the expertise of the service provider really coming together nicely. We actually working on something similar to this in Europe with both the lead operator and a large industrial player. Uh, it's early stage, but we're very confident that this will come into a win-win for all three parties.
And Caroline, we've been talking so far a lot about LTE private networks. We're moving on to 5G private networks. Do you see 5G being used alongside Wi-Fi in private networks?
Oh yeah, we actually seeing that today. We have that in early deployment. We have it both in SA and NSA non-standalone, standalone scenarios, and with Wi-Fi. No one's going to rip out. Wi-Fi is ubiquitous already today. We don't expect the enterprise to go ripping things out. We really see, I think early on that Prasad mentioned it, use the right connectivity for the right purpose. When there's a very complementary role with Wi-Fi 6 and 5G. Sometimes you use Wi-Fi 6, sometimes you use 5G. We here at Intel, when we provide a reference solution, we really provided that such that both of them coexist. That's why it's called multi-access.
Yeah, we see them being complementary as well, 5G and Wi-Fi. I think the point I'll add to Caroline's point is anywhere where you're going to go outdoors, that's really where you're going to see private 5G start to shine in relation to Wi-Fi. And we see that in ports and mines and situations like that, where they're moving these huge vehicles autonomously through these ports and mines. And currently they're connected through Wi-Fi, and they do experience a lot of downtime just due to the fact that it's really hard to engineer a Wi-Fi network outdoors. And so port operators and mine operators are really excited about the potential of private 5G to run these massive autonomous vehicles through their premises. You know, every minute that these huge machines are down is a real solid hit to their bottom line. And so they're really interested in any technology that can help them create more of a five nines experience and create more uptime for their vehicles.
And Prasad, I take it then there's benefit in having more than one type of access network.
No, absolutely. I mean, look, and again, going back to the school to home context, the foundational wireless ubiquitous network has been Wi-Fi for the past decade. And it's been super easy to deploy this. And it's kind of the first thing that communities as well as schools deploy to access the internet. But as you get to richer media, especially video and streaming media, and leveraging higher efficacy educational tools that are going to leverage remote learning with augmented reality and other forms of higher learning for visualization, we are going to need higher quality of service, predictable service to afford this kind of bandwidth at the right cost point. And frankly, for those scenarios, as well as coverage and seamless roaming and mobility, Wi-Fi as a technology is not suited for that. And so while Wi-Fi will coexist, as Caroline has said, and so has Jeff, these emerging use cases that are requiring rich media, low latency, with the right level of responsiveness in large coverage areas, like the community for online job training with rich visual aids, or doing remote learning for kids using Zoom and other technologies with high levels of visualization is going to require a new protocol and a new technology like private LTE. So I think they'll coexist, but I think these emerging workloads will drive a propensity towards the private LTE network.
Okay, now we've been focusing somewhat on the US market, but as we look beyond the US, do you think it's possible to scale the private network blueprints into other geographies? Prasad, what do you think?
Absolutely, and I think while these other countries don't have free spectrum like we do, like CBRS, as Jeff was mentioning, this particular blueprint of enabling a local network with the right quality of service and predictability can absolutely be accomplished with players like AWS, who will provide the compute and the application servicing either on the edge or in the cloud. But the radio access network will be enabled through the mobile edge connectivity capability that the telcos will provide in a metro area or in a local zone, working with players like AWS, leveraging Intel's silicon as the substrate for leveraging the radio access network. And so I absolutely think that that's going to happen simply because of the cost economics and the sheer need of these new workloads.
And Jeff, even without dedicated spectrum to enterprises or other non-telco players, there's no reason to suspect that private networks won't be able to scale up elsewhere in the world.
Yeah, I mean, that's why we've built the blueprint that we've built at AWS using edge compute or edge cloud services such as AWS Outpost and the AWS Snow family. Really allows you to use that same blueprint and use them anywhere in the world that you can get spectrum. And we're involved in several geographies around the world with private wireless. And it's a really exciting time. We're doing things in South America and in Asia and in Europe, regardless of if the spectrum is available or not. And that's largely due to the service providers making such an investment in this space because they see the need from enterprises. And so I definitely think it's a blueprint that can be pushed out everywhere. The other thing I'll mention is the ecosystem of network equipment vendors that we're working with, that Intel's working with as well. These software functions, every day there's more, more impressive work that these guys are doing with making their applications cloud native, making them fit into an automated framework, and having them run on AWS cloud. It's getting more and more exciting, and I think people around the world are seeing it, and I think they're excited about what it brings.
Thank you, Jeff. Well, a final question to all of you. What, in your opinion, are the key barriers that could keep private networks from becoming ubiquitous? Caroline, let's start by hearing your thoughts.
I think that everything that we talked about, some of the legislation concerns that Prasad really mentioned, what we're trying to do here is to really make it easy. It's not just the hardware network in the box. We already put out a reference design to the large ODM community, but the software to drive enterprise at the end needs business solutions. You need to drive software innovation. So we need to invest heavily into enabling the software developers to come on board to develop software on 5G private networks. A lot of the work that we're doing with AWS would definitely facilitate that and make it ubiquitous. It's just like people write things for the cloud, for the enterprise, they should be writing it with the 5G and LTE in mind.
Thanks, Caroline. And Prasad, what do you think are the key barriers that could keep private networks from becoming ubiquitous?
Yeah, and I think Caroline said it really well. There are two pieces to this. One is in the technology space, the ease of deployment, this concept of network in a box, where you're able to essentially deploy the componentry, but there's self-discovery of these components in the network at the time of deployment. And the network is just stood up much like a push-button scenario for the community or the school through the IT department versus a a set of PhDs who are needed to actually do this deployment. Really, that's one. And I'm very confident that we'll move very quickly thanks to the leadership of AWS and Intel and the radio access network technology providers. That's already happening. I'm more worried about the legislative side of this equation, where the legislative bodies really have to promote and encourage the use of private LTE technologies on an equal footing with traditional public networks or Wi-Fi in the way it's consumed, with the right subsidies that schools afford today with E-rate, where these private network capabilities are not part of that subsidy. And secondly, with funding for emergency connectivity broadband like ECF or the infrastructure bill, I hope that the ability to deploy private LTE networks is not an exception, but it is a promotion to enable equal play and the democratization of broadband, as I said earlier, because that will drive a very accelerated reduction in price, as well as the right quality of service with reliable broadband for the masses.
Thank you, Prasad. And Jeff, what are the barriers that or potential barriers that we need to be aware of?
Well, I think globally it would be spectrum availability. I think that's one thing that could hamper how ubiquitous private wireless networks become. In the U.S., we've started solving that with CBRS spectrum, and places like Germany have solved it with their spectrum availability as well. So I think that's one area that's going to have to be figured out in a lot of geographies around the world. I think the other thing is, as Prasad said, the deployment challenges. We've got to make it easier certainly for schools to deploy private wireless, but also we need it to be more of a plug and play model, even inside buildings, inside factories, inside warehouses or shipyards. We really have to remove the friction and really make that an easy operation for IT organizations that are not extremely knowledgeable in 3GPP technologies. So I think that's a lot of work that we're doing at AWS to help solve that, but I think that's one potential barrier that's got to be solved.
And Prasad, a final comment from you?
Yeah, one additional thing that I would just add to what Jeff said is the managed service providers who provide these networks are still emerging, and anything that corporations like AWS and Intel could do to accelerate the ecosystem that will provide the after-sales support of these networks at an affordable price is very much needed. It's happening, but this is just a plug to accelerate that.
Thanks, Prasad. And that brings our discussion nicely to a close. Thank you all for taking part today and sharing your views and experiences.